in class, so here's number 8. For the function below, at what labeled points is the slope of the graph positive? Okay, first of all, I want to identify all the ones where the slope is 0. So the slope equals 0 for B and E because those are maximum values. If we had a point down here, the slope would be 0 here as well. All right, positive slopes occur when the graph is increasing from left to right. So from left to right, A is on a increasing part of the graph. So A has a positive slope. From B down to here, all of these graphs, this graph is decreasing. From here all the way up to E, it's increasing, and D is on that part. And then from E onwards, we just see a decreasing graph. All right, negative slopes occur on that decreasing part of the graph. So like we just said, C is on the decreasing part of the graph, and so is F. At which point does the graph have the greatest, meaning most positive slope? All right, so our positive slopes were A or D. A or D. So the way I'm going to determine this is basically proximity to a 0 slope. Here we have B has a 0 slope and A is all the way over here. And right down here we would have a 0 slope and D is all like here. I would say that D is actually closer to a 0 slope, than A is. So I'm going to say that A has the most positive slope. All right, least slope, which means the largest negative slope. Okay, so let's look here. Our two options are C or F. I'm going to use that proximity to 0, a 0 slope again. So here's a 0 slope, and there's C right after it. E is a 0 slope, and F is way further away. So if you think about it, if this was a velocity graph, right, the velocity has gotten a lot faster by the time we're at F. So F would be part of the most negative slope. All right, number 9. We're going to estimate the slope of the graph at these points, x1, y1, and x2, y2. So the slope at x1, y1, and the slope at x2, y2. All right, slope at x1, y1. Let's look right here. It's at a maximum. The graph over here had a positive slope and then a negative slope, so I'm going to say that slope is about 0. All right, x2, y2. Not at a maximum or a minimum, so it's not 0. But I'm going to use this tangent line that they drew in to kind of approximate it for me. So I'm going to look from down here to, I think this one goes through right there. So I'm going to go 1, 2, 3, 4, 5 is the rise, over 1, 2 is the run. So 5 halves is what I'm going to say. 1, 2, 3, 4, 5. Yep. Okay. All right, let's look at B. We're going to have our slope at x1, y1, and our slope at x2, y2. And once again, these are approximations. So if you're getting similar numbers but just off a little bit, that's totally fine. x1, y1's right here. It's on a negative slope, so I'm going to be sure to make sure I know that's negative. And it looks like we are going to go 1, 2, 3, 4, 5 units down and 1, 2 to the right. So I'm going to say negative 5 over 2. x2, y2 is on a positive increasing part of the graph, so it's going to have a positive slope. And I'm going to approximate its slope by saying 1, 2, 3, 4, 1, 2. About 4 for my rise and 2 for my run, which would be a slope of about 2. All right, number 10. For the graph y equals f of x shown in the figure, arrange the following numbers in ascending order. So smallest to largest. And we have 6 things that we have to order. We have to order The slope of the graph at A, slope of the graph at B, slope of the graph at C, slope of line AB, the number 0, and the number 1. So, first of all, looking at all of these, A, B, C, the slope at all of these points, they all have positive slopes associated with them. And none of them occur at a maximum or a minimum, which is how we would get that number 0. So I'm going to say that 0 is the smallest thing I see here, because none of these points has a negative tangent line, and also none of them is a max or a min, so none of them has 0. All right. Well, if the smallest number is 0, the next one is going to be the slope whose tangent, the point whose tangent slope is as close to 0 as possible. Now I'm going to say A is a pretty steep slope, B is less steep, but as we get out to C, we get closer and closer to a slope of 0. So I'm going to say the slope at C is the next biggest thing. I think it's a little bit more than 0, but it's not 0. All right, next one. So I got that. I got number 0. All right, so now I have to decide what's the next thing. Well, I see two things. A, I'm pretty sure the slope at A is going to be my largest thing, because if I look, it's on the steepest part of the line, and that line looks a lot steeper than the line AB. So I'm going to say my largest thing is the slope at A. That's going to be my largest thing. All right, so I got rid of that. All right, so let's talk about the next thing. We got 1B and line AB, and this, it's definitely a good thing right here. We're looking here. We've got this line y equals x right here, and the slope of the line y equals x would be 1. All right, so do we think that the tangent line at B has a slope that's bigger or less than 1? Now, if I kind of drew in a tangent line right here, if I kind of imagine that, right, that slope would actually be less than 1. So I'm going to say that the slope at B is less than 1. Also, looking at this right here, from A to B, that line that's drawn in, that has a slope that is less steep than this line, this y equals x line. So I'm going to say that the slope of AB is also smaller. And then that would mean that the number 1 would be right there. It's more steep than AB, that slope, or the slope at B. All right, last but not least, we want to figure out, looking at these position versus time curves, for 4 different particles moving on a straight line. For each particle, determine whether the instantaneous velocity, this basically means the slope, or the IROC, is increasing or decreasing. So we want to know, are our slopes increasing or decreasing? Right here, we have pretty steep slopes, and as we get closer and closer and closer, we get less steep tangent lines. So this, the IROC, is decreasing. Let's look here. Tangent line, tangent line, tangent line, tangent line. As you see, those tangent lines are getting steeper, so the IROC is increasing. Tangent line, tangent line, tangent line, tangent line. The instantaneous rate of change is decreasing. Tangent line, tangent line, tangent line, and so on. The instantaneous rate of change is increasing. All right, the only additional thing that you need to study is the definition of the derivative. That's finding the derivative of something using the limit as h approaches 0 of f of x plus h minus f of x over h. Okay? So besides sketching graphs, that's the only other thing. Good luck.